All right, so let's keep going. Next, I want to teach you about independent samples t-test. So if you recall from lecture, the independent samples t-test is when you want to compare differences in means between different groups or different observations. So in this case, say for instance, we don't care about the sales after an event compared to some sort of a mean, but rather maybe we care about how sales after the event compare between city A and city B. So you may recall that in the values we have 3 cities though. So city A, B, and C. Well, why can't we compare all 3 of them? And the reason is simple. A t-test can only compare up to 2 values or 2 variables. So in order to tell SPSS what we want to compare, we need to make it obvious that we're comparing either city A and B or city A and C, right? Or city B and C. It cannot compare all 3 using a t-test. However, I'll do a bit of foreshadowing to say that later in this video, I'm going to teach you about ANOVA. An ANOVA, especially a between subjects ANOVA, is essentially an independent samples t-test, but where you can look at 3 different values all at once. Okay, so stay tuned for that. I should say, next episode of the amazing series, or however you want to word it, we will look at ANOVAs later on. Okay. So let's cancel that for a second and come back to our hypotheses, right? So our null hypothesis is there is no difference between city A and city B regarding after event sales. And our alternate hypothesis is there is a difference between city A and city B regarding after event sales. Okay, so how do we test that in SPSS? So as I said before, the first step you should always do is analyze descriptives, frequencies, and look at a histogram and look at the skewness and kurtosis values. We've already done it in the paired or in the one sample t-test video. So if you would like to look at how that's done, please go back to that video and you can see the steps to do that there. Okay. Now we're going to go straight into compare means. And as I mentioned, we're going to run an independent samples t-test analysis. So the box that comes up gives you a little bit more information than it did in the one samples t-test. Here we want to test the variables sales after the event, right? We want to know how did our sales perform after the event related to our 2 grouping variables. Do you remember what they were? In this case, they are related to city name. You'll notice that when I put city, you get city ? That's not SPSS getting confused. That's SPSS telling you that you're missing some information. So what we want to do is we want to define the groups. And the reason we need to do this is because we need to tell SPSS, which cities do we want to compare, right? We could be comparing A and B, B and C, or A and C. So we need to tell it. We want to compare city A against city B, and those are labeled as 1 and 2 respectively in SPSS. So we're going to use our specified values. Group 1 is 1 and group 2 is 2, and then continue. Next, as I always like to do, click options. You're not going to make any changes here, but just confirm that you have a 95% confidence interval and that you're excluding cases analysis by analysis. If you'd like to hear more about why we select these options, please refer to the one samples t-test video. We're not going to do any bootstrapping here. It's out of scope of this course, but sometimes you need to do that if you're missing a certain number of respondents in your data set. That's not necessary here. And then we'll keep this estimate effect sizes box checked. Once you're ready, we'll hit OK. And here we have the results. So the first thing you can do is confirm the N, that is the population size, for each of the sales to make sure that those two cities are similar in size. It is important that the two are similar because you want to make sure you're comparing equally across two different groups. It wouldn't be fair, for instance, if city A only had one sales number to report and city B had 50, because that one number wouldn't be accurately reflecting a mean. So the more close those two numbers are together, the better. Okay. We can also look at the means, standard deviations, and standard error means, just as we did in the one samples t-test video. So here we can see that we had 27 observations for city A with an average unit sales of 147 units, right? It's units, so we have to express it as a whole number, with a standard deviation of 14.471 and a standard error mean of 2.785. This 2.785 is simply the standard deviation divided by the square root of the population. Same for city B, we have 25 observations, 165 mean, standard deviation of 18.043, and a standard error mean of 3.609. Let's look now at our independent samples test. So now that we've confirmed that the two groups are about the same in size, the next thing we want to do is test for the equality of the variances. That is, we want to make sure that the groups themselves are homogeneous. In other words, we want to make sure that all of city A is similar and all of city B is similar. Okay, this is called within subject variance. And it just confirms that, I'll give you an example here. So it confirms that, for instance, imagine city A had a mean of 146, and we found out that half of the city, half of the observations, so about, let's say, 13 or so, had a mean of one sale, and the other half, 14 of them, had a mean of, or sold about 300, right? You might end up with a mean of 146, but that doesn't actually mean that on average they're all selling about 147 units. There's actually quite a significant range between the two of them, and the standard deviation and the error would catch that to some extent. Fortunately, in this case, that's not a problem. Our standard deviations are quite low for the means that we have here, and therefore we can surmise that city A has equal variances and city B has equal variance. To confirm it, we need to do what's called the Levene's test for equality of variances. So if you look here at the significance level, we confirm that the equal variance is assumed. We want this to be above 0.05. So unlike the t-test, where we want it to be below 0.05 to look for differences, here we want the opposite. We want to make sure that each city is not different from itself. So therefore, we want this number to be above 0.05. If it is, you'll refer to the top row. And if it's not, it's okay. SPSS will still do the analysis, but you'll need to refer to the bottom row instead. And that would come up as a limitation as well in the study. So in this case, because the significance level is above 0.05, we assume equal variances and we refer to the top row. So that's the only extra step when looking at an independent samples t-test. Going forward, it's the same process as a one samples t-test. So here we look at the significance. Two-sided p is less than 0.001. This is a very significant result. So we can say from this that regardless of what the t-statistic is, we'll look at that next, but before we look at the t-statistic, we can confirm that we have a very significant result. And we just want to know how significant that result is. So we move over to our t-statistic and we have negative 4.220. So this is saying that when we take the difference between the means So 146 minus 165, you'll have a negative number, right? And then divide that by the standard error means, we result in a t-statistic of negative 4.220. So these two numbers, our significance and our t-statistic, we use those together to confirm that we will reject our null hypothesis, and we conclude that there is a statistically significant difference between city A and city B in terms of after event sales.